With ever-increasing amounts of data at the fingertips of developers and engineers, we are pushing the limits of what the human brain can process on its own. Developers and engineers who rely on large quantities of data need to find ways to process it efficiently. Fortunately, there's good news. We don't have to. Using machine learning, computers can actually excel at these tasks. You just have to teach them how. At the simplest level, machine learning is the process of enabling systems to automatically learn how to perform certain tasks without being given explicit instructions. These tasks can vary, but they often include creating predictive models, which are data models that can be used to make predictions on incoming data. Consider an application that helps users predict the value of their house in a given real estate market. There are a number of different factors that go into predicting the value of a house: its square footage, location, number of bedrooms, and more. These individual properties of the house, and likely many more, are known as the features that will be used in your predictive model. In machine learning, features are the individual measurable elements that serve as the input to your models. The output of your model will consist of probabilities for various labels. Labels are the measurables your model is trying to predict, such as the estimated value of a house, given its features. So, provided a dataset of houses that includes these features and associated probabilities for labels, a machine learning algorithm can learn the relationship between those features and labels to create a model for predicting the values. Many different algorithms for creating these predictive models exist, and data scientists can hone and optimize their algorithms for a specific workflow. So, how do these predictive models learn to correctly interpret the data they receive? By providing training data, which includes both features and correlated outputs for labels, and machine learning algorithms, the model can be trained to better understand these correlations. When combined, these create your model, a function that uses input data features to make predictions on labels. This function, in principle, is no different from a function that a human developer might write to predict values. We're just using machines to create and refine them. Machine learning like this is used in virtually every industry today. In healthcare, a model might be used in an application that predicts whether a former patient is at risk of being readmitted to the hospital. This allows their care team to step in prior to the patient being discharged, potentially saving doctors and nurses time and effort. In finance, machine learning can be leveraged to help detect fraudulent activity on someone's bank account or credit card. Machine learning even enables tasks you don't think twice about, like ordering a cab from your phone. The dynamic pricing systems of the cab company's apps use various pieces of information to determine the cab fares that you see. If you think machine learning can help your application produce better results, but you don't have a team of data scientists at hand, there is finally a solution for you. Within InterSystems Iris Data Platform, Integrated ML enables developers with SQL proficiency, regardless of expertise in data science, to take advantage of machine learning within applications. Using Integrated ML, developers can use familiar SQL syntax to create, train, execute, and validate machine learning models. If you're ready to start capitalizing on the massive amount of data before you, try Integrated ML on InterSystems Iris Data Platform.